Well, hello, and welcome to today's lesson where we're going to talk about representations of matter. So the goals of this video, there's two of them. First, at the end of this video, you should be able to identify and explain the differences among observations of matter at the macroscopic, microscopic, and particulate levels. And then goal number two is you should be able to define the term model as it's used in chemistry to represent pieces of matter too small to see. So before we do that though, just a simple definition, matter is anything that has mass and that takes up space. And there's several different ways that we can observe matter in our world. So the first is the one that we're all used to, is macroscopic. These are things that can be observed with the naked eye. A few examples given here: mountains, Starbucks coffee mugs, hopefully filled with coffee, and other things like, the height of a human, a sheet of paper listed down here. Those are macroscopic things. So when we can't see something with our naked eye anymore, then we're thinking about things that are microscopic. And of course, we need the aid of an optical microscope to see these things. All right, so these are things like a plant cell. Or, for example, I have a plant over there, kind of off camera, that I could see the leaf. The leaf would be macroscopic, but the cells of the leaf would be microscopic. So then finally, there's the particulate level. These are things that are too small to see, even with a powerful optical microscope. So for example, atoms, caffeine molecules, all right? My favorite, these are things, again, that have specialized, or you need specialized techniques to see them, like electron microscopes, scanning tunneling microscopes, because they're too small to see even with an optical microscope. And why is this important? Why am I bringing this up? It's because in the laboratory, chemists do experiments on the macroscopic level, I would say, at least most of the time, where you have a beaker maybe filled with a chemical, and that beaker, you're doing an experiment with it, the chemical's in there. But what you're really thinking about is how the chemicals and the particles and the elements are interacting on the particulate level. Okay, so in other words, chemists think here. And like I said, one of our goals in this class is to think like a chemist. So that could be tricky, of thinking of things on the macroscopic level or viewing things on the macroscopic level and having to imagine what's going on at the particulate level. But that's something we're going to work at together throughout this course. So if you can't do it now, or you have trouble doing it now, don't worry. But at the end of the course, I'm sure you'll be a lot better at doing that. So here's an example problem to see if we kind of get this concept down. It says classify each of the following as macroscopic, microscopic, or particulate. Well, the first one is easy because we kind of already mentioned it before, but atoms are too small to see even with a powerful optical microscope, and they definitely can't be seen with the naked eye. So this is particulate. I'll just abbreviate it. What about iron filings here? So, shavings of iron that you may have played with a magnet before. So what about them? Well, they're small, but I can see them with my naked eye. And that's the key here. I could see them with my naked eye, so they are macroscopic. Okay, macroscopic. I apologize if my handwriting isn't the best. I need to get a better pen for my tablet. So what about a bacterium? Well, if you looked at the chart just a slide back, you see that a bacterium can't be seen with the naked eye. And I think we know that from common experience. So I can see a bacterium with a microscope though. So bacterium would be microscopic. Doesn't like the C there, microscopic. Okay, so again, a silver atom is particulate. Can't see it with a powerful optical microscope. Iron filings, I can see with my naked eye. They are macroscopic. A bacterium, I can see with a microscope. So that's the classifications here. So, like I said then, we want to see things, or a chemist wants to work on the macroscopic level, but think and see things in their imagination on the particulate level. So chemists use models to do that. So just like a geologist would have a model of the Earth, which is a globe, the chemist uses models to represent things on the particulate level, to represent atoms and molecules. So the most common one that you've probably seen before is a ball and stick model, which symbolizes atoms as balls, okay, right here. So that's an atom, and that these connectors here represent the bonds between the atoms, okay? So that's one way a chemist might have like a model kit to make these little plastic models like we see here to represent a molecule on the particulate level. Another thing they might do is a space filling model. This is showing the outer boundaries of the particle in three-dimensional space. So again, two representations for a particle that we'll see throughout this course. So finally, for this video, we'll just say, here's a ball and stick model for water. Okay, so these guys would represent hydrogen. We'll talk about the element symbols later in the class. And here's oxygen right there. So again, models are models are represented in writing with symbols. And we would know water represented in writing would be H2O. And in this representation that we'll become more familiar with as the class goes on, about how the molecules are bound together, but it does represent the atoms involved in making the molecule. And it can give us some more information too, as we'll see later in the class. So this is just kind of reiterating what I've said already a few times, is that chemists make mental transformations between visible macroscopic matter, like liquid water, okay, and written symbols like H2O, where, you know, we might use that to serve as a simple reminder of the. All right, so that's for today's lesson, and in next lesson, I believe we're talking about states of matter.